So, how is the assignment going? Were you able to finish the quiz and did you did you attempt the problems as discussed in the last session? Hi, Sai. So, okay. Yeah, there was a quiz too. The session one quiz, not the session two. The session one quiz. So that must have been finished after session one itself. Okay. Let me check once. All right. Okay. Excellent. And when we are talking about MapReduce, those who are interested can attempt to multiply matrix. So if you have seen our website, and over there I've posted a problem called multiplying a matrix using MapReduce. So you have two metrics in this form. Okay, you have two metrics in the form row, column, and value instead of having array. So 0 0 some value, 0 1 some value in that format. Okay, so you have got a great matrix, and these kind of metrics you have to multiply using MapReduce. All right. So this I did as part of a 15 minutes challenge. Okay. So but you should attempt it. It is quite interesting way to try it out. All right. This code may not work because there is no proper indentation. Um, I we need to do a pre over here to make it proper. Right. So although the code is correct, it is just in displaying the tab has been removed and hence this Python code may not work. But conceptually it's correct. But first you should give a try. This is a very important problem to solve. Other than those four problems we talked about, uh, those four problems for 1, 2, 3A, 3B, and 4 we solved last time. And after our discussions on the solutions, I had requested all of you to finish those problems in your own language. Okay, that will give you a great amount of confidence. And then we closed our previous session with a question about suggesting the next word. All right, suggesting the autocomplete. Right. Other than that, if you are really enthusiastic about writing MapReduce and how to convert any complex problem into MapReduces, you should actually try the matrix multiplication. All right. And if you are going for a architect's role in a big data or distributed computing, uh, matrix multiplication is fairly common question. Right. So although although for other roles it's actually difficult to solve, but still there are few people who are really looking for, say for example, if you're going for a linkedin interviews or maybe Amazon interviews, they'll ask you how do you multiply two metrics in a distributed manner, right? So try attempting it. It will be fun. Just remember that this is the representation of the matrix. Instead of a usual way of representing matrix, it is I, J, and value in that format. The row, the column, and the value at that point. So there are so many in this tabular form, three column format. There are so many values, and that represents a matrix. All right. So this matrix problem is clear to you. All right. If you get stuck, right. It's like an image too, exactly. So the way most of some of the formats represent an image is the coordinates and then the color, I, J, and this color. Okay. On 0, 0, the color is blue, then and the color of the pixel on that particular point. Right. Good. Good. So yeah. So Virdi, maybe you think about this problem, and then probably you will be able to come up with the things you were discussing last time. All right. So yeah. So did anybody attempt the autocomplete problem, the happy and then birthday problem? Let me just quickly open that problem. And the last one was this one. Yeah, this problem. So first assignment was finish all the code, and second was given a word you have to give an auto suggest. All right. So we'll discuss a little bit about this second problem. Yeah. So so the problem statement again I'm repeating, based on a content from a large text archive, you have to formulate you have to formulate the next words for recommendation. All right. So say there is a huge text available from Wikipedia, and all you have to do is go through all your code has to do is go through the whole Wikipedia and then form basically this kind of a recommendation. All right. These are the top five words which come after the word called happy. So what do you do? How would you break this problem into MapReduce? Okay. Let me again simplify one step further. You are given a huge text in a single file. All right. Huge text, say 200 GB. Okay. You're given 200 GB text in a file. Now what you have to do is you have to form these kind of tuples. Anyone just I'm not looking for a finished solution. Just give me ideas here. Just give me ideas. Count words that come after keyword and whatever scores display them. Yep, yep. Now how do you break this into a map reduce? The counting problem, the how do you break this counting problem into a map reduce kind of mechanisms? For your map function, what should be the key so that you get the most frequent word just after a word as the key? So if you do, okay. First step is to create tuples as pairs and sort it. Perfect. Okay, okay. Okay. Good, good, good. And yes, perfect, perfect, perfect. Great, great. So I'm giving another approach, similar approach, and then perfect with these very correct in the answer. Now this is first attempt, all right, and you pinpoint the problems to me. So is anybody else is having problem with my voice? Is it dampening again and again? It's not clear. Okay, okay. Maybe somewhere internet connection is giving a little bit problem. All right, all right. So now we have one of my approaches and one of Virdi's approach. We'll talk about Virdi's approach in a minute, and also you give your other approaches. So my first approach is I make the key as the first word and the value as the second word, right? So how are you gets converted into how are, how is the key and r is the value, and are you then second key is r and the value is u, right? So all the words which will come after how will be accumulated together. In the similar way, all the words that are coming after are will be accumulated together. Now, what is the problem in this? And reducer will basically do the frequency analysis of each word which is coming after, right? Do you see any problem? Is this approach clear to you? So Mapper basically converted this text into key value pairs, first word, second word, then first word, second word. So all the words that when this reducer runs right on this text, all the words that are coming after how, right, will be their key will be how, right, and they will be accumulated together by Hadoop, and then reducer will do the frequency computation of values and give the results. What are the problems do you see with this approach? Duplication in the sense, so in the values, if there are how r twice, r is there twice, then what will you do? There is that you mean by duplication, Makan? Happy word is there, but it may not be used after how. Yes, yes. Okay, okay. Okay. But happy and how are not related anyway as per this context, Rajnikant. So I did not get it. So happy word is there, but it may not be used after how. But happy word is not to be used after how, right? I with these I meant there has to be the key once and value next. So even if their key is duplicated, right? So MapReduce will bring all the values of that key together, right? So those keys will come together. Reducer's job will be to deduplicate and count the number of keys which are coming highest and then do. So any other problem than that? I see actually 3 to 4 problems in this approach. Okay. So should I explain this approach again? So when I'm typing how, it should show me R or U. But why should it show me right? It should show you R when you're typing how because R has come and not happy or birthday. So it won't show you, right? Because as a result of this thing, so key is first word and value is second word. And when we do, see the overall objective is to reach to this one, right? Top 5 words based on what you typed just now. And trust me, this is how actually Google does when you type on the keyboard. No, this approach might be different, but overall strategy is similar. Yeah, both, Virdi, both. Because in case of big data, if minor performance problem will become a humongous problem and impossible to solve. So performance problem is equally a issue. I was meeting up some people from my previous company called InMobi, and I'm talking about the performance issues. Okay, so they they had these servers needed more memory. They kept on increasing memory till 200 GB, and they still wanted more, and then they gave up. And then they said, "No, we'll do it again. We'll develop the whole product from bottom up." So performance issues are real. I mean, I could not believe that the people use 200 GB as RAM. Yeah, it does actually. So the 64 bit architecture can use up to quite huge memory. Only is the 32 bit which takes about which can maximum use 3.3. Yeah, exactly. That is the problem with this. So hardware being cheap and then people have when they have a they get convinced into this psyche that hardware i- is enormously available, and that is the mistake they lots of people make. They start thinking that processor, memory, and these things are not a bottleneck, and that is the main issue with most of the psyche of the people. And but when it comes to right big data, right, when you're handling terabyte of data, you cannot have a terabyte of memory, RAM, at all, right? Yep. So okay, so I'll go ahead with my approach. So there are first problem I foresee with this approach is this. Okay. Now, yes, in this example, also we will need twice as much as RAM as the text. Yep. If we do it normally, then we will require that much of RAM. But if we are using a map reduce, you don't require a RAM. I mean, you don't require huge RAM. All right. Any amount of RAM will do for you. Okay. So actually, a better strategy. So computation of frequency can be further mapped, right? So let me, the approach which Virdi is saying is good. So here what I was talking about as part of the first map reduce process. Can you see my screen? I'm typing in a text editor. Alright, so let me just increase a bit of font. So how let's say there was one more sentence. How do you do? All right. Now I'll start from here. From here. All right. And first sentence is this. So how are you? And then Ram, happy birthday to you. How do you and you do, right? So yeah, so where this point is that why there is no u space ram here, right? Why isn't there u space ram here? The thing is, mostly if you use the map reduce by default, it will give you line by line input like here. All right. So that is the reason, and that's exactly the reason why I have pulled out this example. Why I have pulled out this example. That's exactly the reason to demonstrate you that those are the things missing, right? So that is one problem with this approach, because we are picking up line by line. So you and ram tuple, this tuple is not picked up, right? While this tuple is picked up by mistake, because there's a full stop here, right? And if you're doing a normal analysis, the way people do generally, then you will pick up line, break it up by spaces, and pick up the words by words and keep on printing the key values, right? And the other problem with this approach is that, okay, so let me just go through the approach, what I'm trying to portray. So the other problem, and then what you do is you take these words and MapReduce will sort it for you. I'm using my editor sort. So you can see, and these for the key called U, both the words will be grouped together by MapReduce framework for you, and there are no other words here which can be grouped together. Okay. So for you, we have two suggestions, either do or how. All right. While for others, it's not there. Now, had there been some other how, then your reducer will have to go through it again, do it in memory, and then solve it, which is a bad approach because reducer to do the computation of frequencies for a reducer will become a headache again. Instead, instead, a better approach is to form the keys based on a tuple of say how and dash r and then r dash u, and in front of each we print one. Okay, we on the same page? Now let's say how are you, and then ram happy, and then one, and then happy, and birthday one to you one, one, and how do one to you one, and all right. Now this is the key you have prepared is basically the, and we are ensuring the word does not contain the dashes, right? So in this in first shot you will get this, all right, and then what you can do is you can here after this you'll say you will do a summation of all the words which are coming together, and here itself you will do a lot of deduplication. Okay, all right. So you can and in couple of passes you can solve it now. So again, after you have computed the say frequencies here 100, here 1000, and so on, you will then break it into other passes. All right. Into other passes as in then you will make it that way we have done earlier. So it will actually suggest, r- it will never suggest RAM after you. Yes, that's exactly the problem. Now so first problem we tackled was that we were trying to compute the frequency of values in memory or without using MapReduce. So this first approach by making key value pair as a combination will do a lot of deduplication over here itself, and then we can go ahead and only pick up the values which are only top five values from the list. All right, top five values for the list. All right, now let's close this. So try doing it, try building the map reduce for this process. And this is a good exercise actually. Both matrix one and this one, both are good exercise. Right. Now let's, right. So there are two more problems as Vidhi also told. This last word which we are talking about, okay, the last word of the line should pair with the first word of the next line. This you has to pair with Ram, right? Bec- okay. Imagine that how was the last word and R will be the next word. So basically, instead of picking it up line by line, we need to pick it up sentence by sentence. That is the crux. Similarly, the last word of a sentence should not be paired with the next one, right? The Ram should not pair with happy, right? Because they because sentence ends here. So we should not be ever giving a suggestion of happy when a user types RAM, right? If a user types RAM, giving a happy as a recommendation is a mistake, right? So these are the minor problems. Although if you have a huge corpus of text, say few terabytes, then these minor problems will be elevated. But you should be very cautious about churning your data. You should not be making mistakes in churning the data. Okay. Now, how do we avoid this problem? In our previous demos, what we demonstrated, the map reduce, we was picking up line by line. And if we are picking up line by line, how are we going to pair U and RAM, right? When your map reduce has only input available as a single line instead of the whole text, then what can you do to make it such that these two words are together, right? And there is one more problem over here. We will discuss it, right? The other problem which we are going to discuss today is if there is a huge text and and HDFS has sliced this text into 64 MB. HDFS doesn't care whether the boundary lies between your word, between the sentence, between the character. It doesn't care. How does MapReduce handle those kind of issues beneath the hood? All right. And can we convince this whole MapReduce system to give us sentence by sentence instead of line by line, right? So is that problem statement clear? These three problems. Okay, Bhupati, I'll repeat once. So basically, are you convinced that this approach is wrong because you the RAM never came after you. Ideally, it should come, right? As we said that we will break it into tuples, right? We did not come. So that was the first problem. Second problem is that happy is unnecessarily coming after ram in our tuples because we should not be giving a recommendation of happy after ram, right? Because that's not relevant. So that is second problem. Third problem was the computation of frequency that we can deal later, right? Now, the other problem I told was that how does HDFS convert? Because HDFS boundaries are hard boundaries. So if you have a huge uh, text, so and it has to uh, cut the block at say 64 MB. HDFS cuts the block at 64 MB, right? And so that boundary may be in between the sentence, in between the word. How does HDFS actually handle this? Does Hadoop handles it? Right? That is some discussion. Okay. So Virdi's point is that why can't mapper pair U and RAM? He doesn't get it. Okay. Okay. But if it has less frequency than other combination level, yes. Prasant's point is also valid, right? So if you have a huge text, right? So these corner cases will be removed fairly, but still we should not be relying on data to correct our mistakes. Mostly the data corrects our mistakes. Yeah. So let me explain to Virdi why doesn't it pair to. All right. Right. So if you remember in the discussion in our MapReduce discussion, so whatever text is there, it is broken into sets of lines, All right. And then basically there will be line 1, line 2, and each line each line is fed to your mapper. Okay. By So the code which you write, right? Your code, say function map. I'm just writing a very uh, has two things. One is line and other is block size. This is what you get when you are writing your. Here goes your code. Okay. Here you will write your code. Here you will write your code to spit out, right? So you don't have a control right away. You don't have a control over here, right? Because here you only got two things. One is line, other is block size. Okay. Now, how do we convince Hadoop to pick up the things uh, sentence by sentence? That is something which we are going to discuss. Okay. Instead of line by line. This is the default behavior of MapReduce, and we need to work on how do we convince it to pick it up by sentence. Okay. Virdi, is that clear? Okay. Now moving on. All right. Now few very quick questions. So the first question is that the data generated by the mapper is given to reducer and then it is sorted or shuffled. Quick answer? Yes or no? Okay. So let me repeat. The data generated by the mapper is given to reducer, and after giving it to reducer it is sorted or shuffled. Do you think it's correct? So Bhupati's point is that usually map picks up single line even if yes. So that is how the default behavior of MapReduce is, and we will talk about how we can change it. All right. Whole chunk is not provided to the MapReduce. All right. Here your question, my question is right. Mapper should do the initial sorting, and if needed, reducer should sort and suffer. Yeah. So see, mapper is your code and reducer is your code. Remember that part. Whenever we say mapper and reducer, it is basically your code. So whatever data is generated by mapper, before it is given to reducer, it is sorted and shuffled, right? By MapReduce. So the answer to this question is no. Okay. Are we on the same page? Or did I confuse you anywhere? Great. All right. Now the next point. So the reducer is just to remove the duplicates. So if you want to look at it that way, good. So reducer is there to basically remove the duplicates, count it, do the average, or do maybe uh, basically it has to convert an array of values into a number. That is the role of a reducer. Okay. And whatever code you want to write in the reducer is up to you, whether it just counts or removes duplicates, or it does all sorts of things, right? So also duplicates, in case you are confusing it. So in case mapper is giving out key values, right? In case mapper is giving out key values and keys are duplicated. So Hadoop will bring all the values of the key which has come multiple times. Say key 1 has come 100 times. So all the values of key 1, all 100 values of key 1 will be brought together and given to your reducer function. All right. Right. So heavy lifting is not so the beauty of the whole game is your code never does a heavy lifting. The heavy lifting is actually done by our framework. Okay. Okay. The reduce. Okay. Yes, mapper makes the big data comprehensible in terms of key values and then reducer comprehends it. That's a good point. But Java collection map does not allow. Right. So this is not that kind of a map, right? We discussed right last time. It has nothing to do with the Java collection map. The way it is the mapping process. There's a difference between hash map and a mapping process, right? Mapping process is converting one value into another, and that's exactly the mapper function's duty is. All right. So you guys actually need to maybe look at the few exercises which we did and try doing all the exercises which we have discussed today. Okay. In case you're stuck, in case there is a confusion, let me know. I can schedule a extra class in midweek or before the next Saturday to iron out your doubts. All right. If you have any doubt left at all, just drop me an email. Will just schedule some meeting, some session in the midweek. All right. But try at least attempt one or two problems out of the lot. Okay. Mapper can only generate a single key value pair for an input. Yes or no? Can it generate multiple? So if giving a line, it can generate only one key and one value, or it can generate multiple keys and values. So Bhupati, I was actually waiting that you guys will actually drop me an email that you are looking for a regex, because after the session, okay, I was actually waiting whosoever wanted a regex class, they should drop me an email. Just a single line email that need a regex class, and then I'll coordinate. Okay. So okay, multiple. Good, good, good. So Bhupati, just drop me an email because after the session, I'll just figure that out. What time is good for you? Also, in that email, suggest a timing. Suggest a timing. What works for you and what doesn't work for you. All right. And then yeah. So those who want a regex class, just drop an email with the time which works for you and which doesn't work for you. Right. So the mapper can only generate a single value pair for an input value. Good. So all of us are okay with the concept that it is multiple, right? So a mapper can actually generate the keys as many as value as it wants. You can create that WhatsApp group. Good. And all right. All right. Now, So here we are. This is okay for you, right? Next question. By default, there is only one reducer. By default, there is only one reducer in case of a streaming job. Yes or no? Yep. So, okay. So generally maps is run on multiple machines, right? So what happens in case of a reduce is generally reduce is run on a singular machine. Okay. You can pipe right from one set to another. Hmm. Prashant, can you repeat it? I did not get it. Can pipe right from one set to another. You mean to say that keys are shuffled from one reducer to another reducer? Right. So by default, the in case of a the Java map reduce, the probably the reducer can be as many. Okay. And but by default, I think in Java map reduce also it's only single map reduce. Okay. For map reduce streaming process, I'm 100% sure that it is single reduce always if you don't define it upfront. But I'm not sure about the Java map reduce because as per few definition, Java map reduce actually breaks it automatically based on the data size. Yeah. But there is a possibility of having multiple reducers. Remember that part. Okay. So by default, there is a single reducer job, but it can be split by specifying command line or one option called mapread reduce tasks. Okay. And how many tasks you want you can mention. And in case of Java MapReduce, I think it is decided based dynamically. That's what their documentation right now says. But I have not seen any of my MapReduces being automatically having multiple reducers. So how do you know that at a quick glance? How do you know that the MapReduces are multiple? When your output folder contains multiple parts. Right now, in almost all of our example, the output folder contained part dash 00000, only one file, right? We gave a demonstration last time in which output folder our output folder contained only. So yeah, so we were doing a word count problem last time. Under the word count, we tried solving this. Say, let's take a case of output 7. So you see the part 00. If there are multiple reducers, more than one, and there will be multiple parts here. Okay. And all the keys of one part will be in one. Good. All right. All right. Good. Now, the next question is, what is the role of job tracker? Executing MapReduce logic or delegating the MapReduce logic to task tracker? Good, good. Now, next question. The map logic is executed preferably on nodes that have required data. Yes or no? Good, good. All right. Here, the whole of the chunk available on a node is fed to mapper. Whole of the chunk. Okay. Yes, yes. 64 MB. So the answer is almost whole. Okay. The answer is almost whole. Just that if the split is on the boundary, if it is in middle of line, so that line is transmitted to another mapper. Okay. The last line, which is split in half somewhere or somewhere it is boundary is lying mid in the middle of line, so that one section of the line is actually moved to the other split. Okay. So therefore the answer is no. Almost whole chunk is fed to the mapper. So it is generally the situation that whenever the boundary problem is there, like input splits. So input splits, what would want a line by line input. We'll come back to this question. Okay, we'll come back to this question. Don't worry about this. Yep. So we'll discuss this problem, Makhan. So that's very valid point. If it about binary files, it will. I mean, how do we tackle that scenario, right? So Prashant's point is, would there be a scenario where a word is divided between two mappers? So if you look at HDFS, the way the chunk is decided, there are high chances that the whole file, right? So word would be divided between the two chunks. Half of the word lying on one chunk on one node, and half of the word is lying on another chunk. That would be the scenario as in the HDFS. But MapReduce does a little bit smarter thing. Okay, what MapReduce does is it transmits the last word to the next node. The last line, which is sliced somewhere, so that last line is transmitted to the next mapper onto the next node. Only that transmit happens. That minor small transmit happens. Okay. I will talk about how do you control it. So it is basically MapReduce, which is a part of Hadoop. So MapReduce does that. MapReduce logic does under the beneath. Hadoop file system breaks it into fixed size, which is right, and Hadoop MapReduce basically makes sure that say only whole line exists on one machine. Okay, so yeah, so that is an interesting point. Prashant says that how does it keep that integrity? So every line also has information on HDFS that in the actual file where was this line found, and accordingly it is done. We'll talk about it, no worries. In case we write MapReduce, we have to take a no. So by default, MapReduce takes care of it for you. This line thing where half line is on one machine, half line. So MapReduce takes care of that one. But in case you want a little more different version of it, instead of line by line, if you are doing a processing sentence by sentence, then you will have to write your own handlers. Okay, you'll have to write your own handlers. I'll discuss this part. All right. Very good questions. And yeah, So my question, where does Hadoop store? Okay, these are very good questions actually. So where does Hadoop store the results of a reducer, in HDFS or local file system? Quick, this was simple. Excellent, excellent. As we demonstrated in the browser, so our results are stored in this part file, right? We ran we ran our word count example where input was here, this big text file. We read this big text file using mappers and prepared the frequency of the words and stored it in this file. So this is our frequency of word. On the left hand side, on the left hand side, the it's the word. On the right, this is the block number. This is the block number. This is the key, and this is the value. This looks really, really awkward to us. All right. Now, excellent. So we are all on the same page. Hmm. All right. Now, where does Hadoop store the intermediate data, the output of map tasks before sorting? Where does it keep it? So all of your maps are spitting out key value pairs. MapReduce will try to sort it or will keep it somewhere, right? Before giving it to reduce. Will it be HDFS or local file system? Mm-hmm. Mm-hmm. Okay, that's also, I think I should add it. That's a very, okay. Or memory. Ha. Now it makes a little more interesting question. Okay. So in case your files are very big, your mapper basically will consume, each mapper will consume 128 MB, right? If your block size is 128 MB and you have just got a output maybe little bigger than 128 MB, key value pairs would be generally little bigger than the chunk size. Okay. So before sorting the data, does it make sense to put it in HDFS? HDFS means that you might be putting it into network, you might be transmitting it to some other node, or the backup, the moment you put the data there, the backup will start based on replication factor. So is it worth it? The intermediate data of key value pairs, which is given out by map task, does it require to be on the network? Do we need to do all of that? So in case of memory, if you put it in memory, so each of your mappers, if you are running 100 mappers, all of them will consume 128 MB RAM. And in case your power, well, if something happens, so mapper will not give right away an input to another mapper. The whole map reduce process will finish, and whatever is saved into HDFS is then given. Okay. So what Bhupat is saying, what if there is no reducer, right? Then what happens? So see, each chunk will not be too big, right? So each chunk will be a small one, 128 MB. But 128 MB is too much of RAM. If you from the RAM's perspective, 128 MB is too much of RAM. If you are running 10 processes, then you are going to consume 1.2 GB RAM. Okay. No, actually, this is this is something which contradicts. So the output of maps, right, which is unsorted, it's just key value pairs which are unsorted. That data lies in the local file system. So each local file system, each MapReduce running on all of these nodes will sort it and then shuffle it and then give it to the reduce function, and results of the reduce will be saved onto HDFS. But this is intermediate data. The key value pairs given out by your MapReduce is an intermediate data which needs to be sorted and then shuffled across the cluster. Then it makes the sensible data. Okay. Are you convinced that it's a good design or bad design? Okay. So right. Let me repeat. Let me repeat. So we are talking about Hadoop's intermediate output. Whatever key value pairs you are giving, before it is sorted and shuffled and given out, while it's being given out to reduce, so it has to be sorted, right? The Hadoop has to sort it, then merge it with other key value pairs on other nodes, and then give it to your reduce function, right? So this output of your MapReduce, the intermediary one, does it need to be kept in the network? The answer is no, because let this local node first sort it, then shuffle it. Shuffle it as in send few keys to another node and get some keys from another node and form it a or and afterwards it keeps it in HDFS. Okay, whatever after it passes to the node which is running, so there will be a node, one node, two nodes, or more nodes which will be running the reducers, and this output of MapReduce has to be passed on to the reducer node. Okay. So basically, this intermediate data, because this is useless data for long-term perspective, right? Because these key value pairs which are not passed through your reducer yet is is basically a sort of data which does not need to be backup need not to be maintained. So yeah, Bhupati, last time we discussed that part. So in the cases where we don't have a reducer, the other map reduce process kicks in. So that will be apparent that output of mapper will go to another mapper. Right. It is similar to cache. It is similar to cache, yes. So what it does is, as you are writing, so partly it is in the memory and partly it is in the disk. You keep on writing into the memory. Basically, whatever output is being read from your map reducer, your mapper is continuously spitting out keys and values, and it's being immediately first it's being written onto a sort of a queue data structure. From one end it's pushing it, on the other end it's being saved onto the disk. Okay. For the we call it persistent queues. So that sort of data structure. All right. So this is the intermediate data you can think of. So Virdi, am I not clear, or did I make a point? Okay, good. Now, all right. So MapReduce was, I mean, MapReduce. Why are we talking about MapReduce in Java today? First, MapReduce has got a primary support at Hadoop. Okay. And as per most of the Hadoop's behavior can be fine-tuned using Java to a very large extent. Though we talked about streaming jobs where we can write our MapReduce programs in any language of your choice, right? And that streaming job itself is written in Java. Okay. So So Java has got the primary support at MapReduce because whole Hadoop is written in Java for the compatibility reasons, so that Hadoop can run on any kind of node. And therefore, if you need to make a behavioral change at MapReduce level, the way we said, instead of reading line by line, we want to read sentence by sentence. So in those kind of problems, we need to write more and more. I mean, we need to write Java code which can configure and control MapReduce to a larger extent. So so these are the steps I'm going to take you through. Even if you are not, very confident with Java, you will able to figure it out. It should not be that difficult. Okay. So first you install Eclipse, download and install Eclipse, create a Java project, and then you add these libraries, and then change the JDK from 7 to 6, and change the compiler to 1.6. Okay, these two are important because the 7 support is not there in lots of older versions of MapReduce. I think now the newer versions have got. Okay, okay, let me just pick up the project. All right, so yes, 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 yes. I'll walk through that. All right, so Java map reduce example. Now let me close it. Here we go. So this is my project in Eclipse. So you can actually, what you can do is, whatever I have just showed you here, you downloaded that example, unzipped it into a folder here, Java map reduce example, and then what you can do is actually close it, and then this is my Eclipse. I opened Eclipse. I said import general and existing project into workspace, and whatever just now I downloaded it here, my downloads and Java MapReduce example. Here downloads and Java MapReduce example. Under this, you select the trg2 folder, that is training2 folder, and say open. And then it will show you that this tick mark that it found a project inside that folder, and then finish. Is it visible to you? Now let's see what exactly is the problem. It says two errors and unbound class path. Uh, 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 I think my Java has got a problem. So, okay, for time being, I'm posting the direct URL to you. It'll be available after this session. Okay, it'll be available after this session in my courses. Okay, are you guys using my courses here? My courses tab. I've got lot many courses, but you'll get one course under that section. Okay. So under that, if you go into the 13th, yours is the 13th September one, not 13th September. Yours is, yeah, I think it's 13th September. Yeah. Under that, you can this fourth session. It will be available in the fourth session. No, no, the ours is a different one. Yours is 18th October. All right. So here it will be for you. Okay. Okay. Yep. So Prashant, I have got a team who does that. I only take care of the Hadoop and MongoDB. Okay. And MongoDB itself is like 11 technologies. Sorry, Hadoop itself is like 11 technologies. Other guys take care of the Node.js and okay. All right. Now here I just need to look at this and so for some reason my Java machine has been removed. Have they just removed my JRE? Okay, cool, cool. Basically, for you should not be a problem. If you have installed Java in your environment, you can do add library, and there you can see this, and then say select this one. All right. In case you would not require this, okay? You would not require this. This will be sufficient. All right. Now I have got my Java running. It says, okay, these are warnings, so we don't care about warnings. Uh, just like a typical programmers. In case it says that these libraries are not found for whatever reasons here, what you can do is uh, here you can remove, go to again properties, right click and properties, and under libraries you can remove all of this if they are giving error. In only in case of they are giving error, remove them and then add jar under the same folder where we had added not this one, add external jars. Okay, here and here Java map reduce example which you will download, there'll be a libs folder. Just add all of those and then you forget about errors. Okay, there are all libraries which are required generally are there in that folder. All right, so basically in this folder there are two folders. One is libs, which contains all the libraries. Libraries are collection of uh, code, which basically you can depend upon, some written by somebody else. And this is your code. This is output generated by compiling Java class, and this is your code. All right. Now let me just take you through the code. So we did these five steps just now. Okay. Installed Eclipse, created Java project, add libraries. Instead of these two steps, all I did was I imported the existing project. All right. The next step is that you create a mapper. Okay. Create a mapper in the sense that you create a class, public class stub mapper, which should extend something called a mapper. And when you are extending a mapper, you can define the output which mapper will be giving. Okay. This is same for all the mapper definitions. Okay. For the first mapper in the keychain, yeah, it should import the libs. You don't have to do the import of libs at all. It should do that. That's Makan's question, right? So we have got the first byte and then we have got input lines. This is okay. Most of the mappers are in this form if the input is from file system. And this is the output which your mapper will be giving. The key of this mapper will be of text type and value will be of long type. Okay. And notice that text and long are different from string of usual Java. So MapReduce guys actually rewrote lots of stuff and they coined their own data types. Instead of using existing string, they use these numbers, these new classes. Now, this is how you define a class for the mapper. All right, you can basically take it as is and just change these two lines. This one, two words, this one, and and maybe you might want to change the name of, but don't not to do that if you're a newbie. Okay, now basically the objective of this sample code is to count the lines as usual with our all examples. So you will have to write a function inside this class you just described with these details. Okay. The key and the value which will be provided to your function, this is going to be your function which is going to get executed, will be provided by the this key and value will be provided by the system map reduced to you, and a context will be provided to you. Key, value, and context. Okay. This is the input to your code. Now, what I have done with this input to my code is I took the value, I took the value, I splitted the value by tab or space, just like I did from the command line. Okay, right. So the context, I'll talk about the context in a minute. So this is the value which is provided by MapReduce. This is the key value which we have been talking all the time. Now we took the value which is line in this case, right? If you're reading from file, the key is the byte count. Okay, key is the byte count of this line, which is equivalent to the line number if you think about it. Okay, not really line number, but byte count means the total bytes so far which have passed. Okay, so the total number line length which you have encountered so far, that is byte. Okay. Now that is the key for your mapper in this case, and the value is the line, the whole line. Now all I did was I splitted the line by space and tab. All right. Did a value of two string gives me a string, and then did a split on the regular expression which says that tabs or spaces. Okay. Now we have got words. Words is an array of word. Okay, and now we can do that, go word by word, we iterate over these words and write it back into the context. Okay, this is the way of giving output as key value. Context.write means I'm going to give you a key value as a result of my map. Okay, so few points. Your map reduce is generating multiple key values. Okay, here we'll have to convert this basic string, which is basic string, into text. The text is what understood by MapReduce. Yep. Context is written by reference. So context is passed to you. You don't overwrite context. Instead, you write to context. Yes. We don't basically we don't change. Basically, we keep on calling functions on the context. Right. So this is like collector. I mean, context is sort of a bag on which you keep on putting your key value pairs. All right. Is it clear to you? Here, long writable means I'm creating a new long value, and the value is 1. This is not L, this is 1. 1 is numeric 1. All right. So this is how you write your map code. Now, after once you have finished writing your mapper code, this is how you will write your reducer code. In the reducer code, same way, here the only thing you need to note is, yes, in our example, all we have done is we have taken a text line by line. Say, if a text is given to me, say, mm, hi, how are you? Okay, this is converted into hi one, how one, and R1. These are the key values. This is the key and this is the value which is being to the given to the context. Context dot write hi and then 1. Alright, this is what is being done if you see. Okay, okay. So I can have a little patience, and yeah, I'll tell you that in a minute. I'll just come back to that. Now this is fine, right? Till here, perfect. Good, good. Now Now we take the case of a reducer. Now we are writing a reducer which takes a key and value. Now here you need to put key value exactly what is the output of your mapper. Your mapper output is this, right? Your mapper's output is key is text. See, text, same key here, same here, and then long writable, long writable. All right. If you whatever type you specify in here, it has to be same way here. And those who are from C++ background, it is similar to the templates in C++ background. Okay, we're defining the type of them, what kind of mapper we have. We are saying that our stub mapper is a mapper who takes object kind of key and takes text kind of value as input and gives out text kind of key and long kind of value as the output. All right. And similarly, the context will also be in the same manner, whatever output is there. And whatever is the output type of your mapper has to be the same for reducer. So all we want is the key and a number, and therefore text and a long writable. And remember long writable because we are expecting our numbers to go beyond the limits of integer. All right. And similarly, here we write a function called reduce, which is given few things, interesting part, which is given a key, okay, and array of iterable. It's an array of, okay, it's a array of values of type long writable, same way like this. Okay, so we are given all this function is saying that we will give you key and array of values and you write your code to do the job. Okay, and similarly we'll go through the values. Here what we have done is we have taken long sum equals to 0, then went through each of these values and summed up, kept on adding that value to sum, so that we have the sum of all the values. Okay, this is equal to saying, this is equal to saying sum equals sum of all values. Okay, this function is basically, this whole function from here, uh, from here to here is basically the sum of all values. All right. Now, once you have computed the sum, you have written it to the output, and which is by the way of context. So anything you write to context goes to the output. So key and our long writable sum. Make sense to you now? So this is our reducer. Now, to stitch them together, what we have done, yes, so it gives the sum of all the values belonging to the same key. Yep, you're right. All right. Now we created a mapper. This is our mapper code, which converted the line into word followed multiple key values, and each key values is like word, and the value is one. Now we created a reducer which takes all the values for a key, okay, and then returns sum. And now we are stitching it together, and we are saying that create a job called conf. So sorting is not your role. Okay. Your role is creating a mapper and creating a reducer. The output of the mapper will be taken by the map reduce and will sort all the keys, bring all the values together and give it to reducer. That is the duty of map reduce. Okay. And because that will have is a very heavy lifting, right? If you have hundreds of terabytes of data, sorting it over thousands of mappers is actually the only thing. When I look at MapReduce, all I see is a huge engine which can sort anything. Okay, so we created a job, we created some jar class, all right, and there is an entry point also. Okay, this is the entry point. So step driver is your entry point, and we defined a main function in it, and in this we tell to the system that this is what you need to do. Your mapper is this class which we just created, your reducer is this class. Yeah. So driver is the main class. Okay. Driver is the entry point of the whole project. Okay. And we also define over here that this is my output. This is the kind of input I'm expecting. This is the kind of output I'm expecting. This is the data type one. Okay. Yeah. You can give any name to stub driver, stub mapper. It is up to completely you. Okay. Because when we'll be executing it using MapReduce and we'll saying execute this, we'll tell the name of our step driver. Okay, we'll have to tell the name of our step driver, whatever we name we give it to this one. Okay, now once you are done, we also tell the file. Here we are saying that our input path is this one. Okay, we are saying that add this file to our job. Okay, here we are just adding as input the first argument given to our step driver. From the command line, when we are executing this driver, whatever argument we have given as first argument, we are giving it to, considering it as the input file, and second argument to this program will be considered as output path. All right, and once it is done, then it exits. Okay, here, wait for completion is forcing this process to wait for the completion. If you don't put this line and say exit, it will exit without giving any results. Well, the process will keep on running. Make sense to you? Is any part unclear? So with your question is answered here. So this is how you provide input path and output path. Okay. So we told MapReduce that these are my files. This is my input file. This is my output file. This is the guy who will convert my lines, my input into key value pairs. And this is the guy, stub reducer, is the guy who will take the key value pairs and give out some results. And once you are done with it, this I mean, once you are done with it, print the results. That's all. Okay. Good, good. So it makes sense to you? All right. Where is txt.class defined? Yeah. So this is defined as part of the core libraries, the classes which we have just imported. If you see, I'll show you the code, and that will give you. So this is my driver, step driver. And here if you say if you see, we are saying import. Okay, so org.apache.hadoop.io.txt, and this txt description is here. Okay, here in the libraries which we have included. Okay, here somewhere, here in the libraries which we have included, this is defined over there. All right, it is basically compiled code of a class called text, and this is the reverse engineered code of that one, what is inside it. Okay, so so okay, that's a very good question. And where does the MapReduce code resides? Any of the data node or each of the data node? Okay, the code that we'll write. So let me first give you a demo. So once I am done with it, okay, there are two ways to. First, you take your code and say file, export, and create a jar out of it. Okay, create a jar out of it. Jar file. I'm saying create a jar out of it. It's like creating a zip out of your work. Okay, so I'm saying just save it somewhere here. Let's say downloads, and call it my word count dot jar. Okay, and then say finish. It says that resource is out of sync from system. This is not acceptable. All right, now export Java and then say jar file. All right, so it has been exported over here. And where is the downloads file? Here, this is the jar which we have just created. We said file export, and then we have this. If you want to see what is there inside it, we can do it's not letting me. Okay, now I'm just wondering. All right, now let's try to copy it to the server, and then we'll try to run it. Okay, so copy as in SCP. So go to downloads, and then I say SCP. All right, SCP, and then I say word count.jar, word count dot jar, and then I say student at hadoop one dot no big data dot com. Sorry, it has to be this way. And don't forget the colon at the end of it. Okay, now let's see if are we able to run it, or is it giving any error. I'm doing SSH. Now I'll just copy it to my own folder, move it to my own folder. All right, so we have got word count over here. If you now if you say Hadoop jar and say word count, okay, right now we have to specify the main class as somebody was asking. The stub driver we need to specify. Okay, the entry point. Now our stub driver is run. It is checking if the argument length is not equal to 2, the usage is this one. So that is what has been printed here. We have not provided any argument, and therefore it is giving us this error. All right. All right. Now we say word count, and then we say input. This is the first argument we are providing, and word count slash output, and we say 8. Okay. Let's see what happens. Here I have not given absolute path location. I have given the relative one. Let's see what error do we get. So it says input path does not exist, right? So, and it is saying here it is saying that input path user student word count, which means it is taking all our paths from student folder. Okay. What we'll do in this case is we'll put sgiri also, because that is where our folder is inside student folder. All right, now let it go. Now let's see what error do we get, or does it run seamlessly. So I said Hadoop jar, and then I gave the name of my stub driver. Here, here the thing you need to note is there is no package per se. Okay. Had it been like I have defined a package over here saying package com dot no big data, then it would be lying in a different folder. Okay. So it is saying that stub mapper is not found, class not found, stub mapper is not found to this job. We need to see understand why that happened, right? Maybe my out file does not contain that one. Right. So so basically we cannot run it right away from the Eclipse. We'll have to upload it on the computer where Hadoop is installed and then run it there. Okay. But to test it, there are various libraries which mimic the behavior of Hadoop libraries, and we'll demonstrate to you that part also, how to test it, keep on testing it locally. All right. Now, why my So it is giving error like, so let me just clean it up. Project clean. All right, and so let me just see what happens inside this folder. Resource is here. This one. All right, this is fine. This is done. Right, right. So basically, this example, if you have a example ready, right, this one which runs pretty fairly fine, then it should do good. So I just need to, this is where I was copying stuff. Hadoop jar word count. Okay, the folder already exists. Now I change the output folder name to output 9. It says running the job. Let's see, we still get an error. Class not found. This is crazy. It says class stub mapper is not found. And did it produce anything? Alright, so let's see. As Giri over here, then word count, then output 9. Okay, nothing has been done. So maybe I need to reevaluate what exactly this guy is doing. Okay, let me again do exported with compile configs. Warnings this. And uploaded. Not running it. Again, I think it's some library issue. We need to debug that problem. Class not found again. We need to actually check what is going on. Maybe the version of the library. Java build path. Should we just try with once with the project and then I say clean. Alright, now once I've built it, I should export it. And after exporting, export class files with compile error, overwrite existing files without warning. I think it's not exporting my class file actually. This is what I realize. Okay, so jar minus t and then I say word count jar. Jar minus x actually extracts everything. This is strange. This is strange. What is going on? What is going on? What is going on? Which jar? Okay. 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 Actually, I have recently deleted all of the Java from my local machine, and probably that is what is creating issue. So is anybody else trying yet? No. So this is my, because this doesn't seem to contain, it is there, right? This is stub mapper, stub driver, everything is there. Okay. Okay, let's just put some package in this. Let's say package sg, and I move it to a folder called move. And then in the stub mapper also, we'll just move everything onto. Alright, now let's just move other stuff also to the mapper. Okay, step test, then step reducer, everywhere. So all I'm trying to do is see if it is because of the, if it is because of the package naming conventions. Alright, so this is how. So project clean. and then I say done. Once that is done, so we have libraries 7 right now. We'll just remove it and add library as some system libraries. Okay, and now let me just clean it again. Cleaned it, export it as jar. Okay, export, and then finish. Okay, now I'll just copy it to the server. Okay, so I'm copying it to the server. Done. Once you have copied, you can now run Hadoop. First, it should give an error saying file already exists, and then we run it again. Let's see what error does it give. Because I'm wondering why did this happen. Is it because, yeah, it's still giving the error. So probably it is due to the Java mismatch. The library which I'm using may be wrong. Okay, okay. Let me just try a few things. So there is training 2. Let me try with the training 2. Okay, this time, hold on. So step driver is there. Step driver, fine. Ideally, it should have given an error over here. Hmm. Oh, finally it ran. Okay. So we basically convert it into a package, then it's running. Yeah. Convert it into a package, and then we are running it like this. So it has run successfully and it has completed. Okay. Now let's see the output. Where did we store the output? In output 1, 2. Okay. Now how do we see the output? Here there should be a in this folder in HDFS. This is where I have been keeping, right? So let's just try to refresh this window. And here we see output 1, 2. And under this, there is this. Do you see this? So it has basically computed the frequencies for us, all the words. All right. Are you with me or I lost you? Okay. Now, good. So basically all I did was I changed the package, I recompiled it and uploaded it again, and also changed my library again to 6, and then I executed it. All right. But for you, this by default, whatever is there should work. Okay. Because for me, there was already a file available there, and that's what was giving error. Cool. In case you get stuck, you can try these things also. And so that was partly our what we had been talking about. What we had been talking about the MapReduce in Java. All right. Now we exported, we SCP'd, then we did a Hadoop jar, and that's it. Now there is a one more nice flag over here. Say you want a particular jar file. Okay, you have your own jar file, or you are using, say, mailer or some specific commands, which is not the default library. Or let me put it this way, there is a legacy code which you want your mapper to be executing. Okay, there is a legacy Java file, and your mapper is depending on that, say, compute stocks example. So you put that as a path in the path, and in those cases in which you want to ship the jar file on which you are depending, you should use a flag called uselib. Okay, uselib. But in case you have many more jars, okay, a better way is this. You define a variable called libjar and an array of all the jars you want to use, and then you can start using them. Okay. So both the things you can use parallelly. And now you can create a setup also for testing, and that should work fine. So here the challenges we were facing again and again was because we had to upload every time to see if it is working. Okay, and that is correct in case of the integration test, as in your logic is good, logic is perfectly working, but you want to test in the real life whether it's actually working. In those cases you upload there. In case you want to test whether your map reduce logic is correct or not, you should try out the step test. So this is the format. If you are familiar with JUnit, then this should be good enough for you. All right, this should be good enough for you. You create a class called step test. Setup is something which is run before your test case is run, and then you write your functions like this and mark it with annotation like this, that this is my test case, this is my test case, this is my test case, right? And this is my test case. So in this case, these two should fail, and I can say in right click on this test case and say run as JUnit test. Okay, and you say Eclipse launcher. Now here on the console, JUnit said that these two have failed because we have written fail in those both of these test cases, while our test map reduce has passed. Right? What we are doing in our test cases, first we are creating a driver. Okay, and to driver in, and we are here forcing it to read our input objects. Okay, our own input file we have provided here. My line number one contains this context, line number two contains this one, and this is what we have provided to MapReduce. Okay, and then we run our map driver like this. So we say whatever map driver we wrote just now, we will run it like that. All right. So this is an example of how can you test your own content, to test using without uploading to the server. Okay. We provided this as an input, and we are just printing out whatever output came in. So this is what the output came in. Okay, and has come once in these two lines, and has come once, class has come once, while is has come twice. If you see these two lines, Sandeep Giri is here, teach map and reduce, and teaching the map and reduce class is fun. And if you fun for fun for say fun, and let's say fun here, just example. So as we run this test case again, you will see that, and to run the test case, you can actually go to JUnit and then run it again. Okay. Now here is come twice if you see in the output. So basically going to the server and asking Hadoop to execute this way is far better if you are running the test, if you are doing a local testing. Okay, this is far better while development. So you write your test case in upfront, and when you write test case, you say that this is my input and this is my expected output, and the way you define input is this way. You define input in this way, the way I have defined it here. Define your input like this, and then right, and then you work on this. All right. Then here you can also say that assert blah is blue. Okay, assert true, assert blah is blue. Okay. Here I'm not doing any asserting, not testing actually anything. There is no test case. All I'm doing is whatever my output is, I'm printing it to the console. No, for this you don't need to have. That's a very good point. Thank you, Makan. All you need is all the jars in your project. That's all. You don't need to install Hadoop onto your local machine. Excellent. But it's a good question. Thank you for reminding me. I forgot to tell you. All right. So do you have any questions for you before we take a break? All right. So as an exercise to all of you, even if you are not from Java background, okay, take a bit of time. Just try out step by step what all we have discussed. Okay. So install Eclipse, create this, import this project, build a jar, file export, and then once you have built the jar, SCP this jar to the server into your folder, and then you can basically run from the command line. All right. Are you guys with me, or have I lost you in the demo? Okay, great, great. And in case you get stuck at any moment, okay, in case you get stuck at any moment, just take a screenshot and send it to me, and I'll reply you immediately, or maybe in a minute or two. All right. And if required, if required, we'll come online and we'll have a look at your desktop. Give me a Google Hangout, and I can see the screen. All right, that should do good. Okay, great. Then we take a little break of 10 minutes break, and let's come back at 9:17 a.m. after 10 minutes. Okay. Now it's 9:07. Okay. Bye bye. See you then. Hi, I'm back. Are you guys back? Are you guys back? Should I start now? Good. Good. All right. So we discussed about how to create test cases and right. And the next one is we finished with the break. All right. So a little bit ahead into the how the splitting is done. So so there is a concept called input splits. Okay. So by default, Hadoop divides files into pieces called splits. Okay. And there is a block size, there is a blocks, and there are splits. The difference between a block and a input split is that input split is a complete uh, input in itself, unlike a block, because block is broken. I mean, block is a hard boundary of 64 MB. All right. While input split is something which makes a logical sense to your program. Okay. So this concept called input splits basically divides the input into fixed size pieces called splits. One mapper instance per input split. Mapper runs on each record of a split. Okay. Input split you can think of as multiple lines. Okay. Multiple lines. And each line is a record. All right. Each line is a record. You can think of it that way. Right. So Hadoop provides you a way to create input splits. By default, it's a text input split. The text input split basically takes the input file, gives you line by line. Line is a record, right? And a collection of lines which are fed to a single mapper is input split, right? So the most optimum size of an input split is actually 64 MB. I mean equal to whatever your HDFS split is. Okay. Then based on input split, the Hadoop tries to run the code, run your mapper code basically on the nodes which are closer to the data. Okay. This is called data locality optimization. We'll cover the data locality optimization today, and how to configure the data locality. We'll talk about that one. Okay. If all nodes hosting a replica of data are busy, then map executes on the same rack. We'll talk about this data locality again. Now let's first talk about input splits, right? So there is something called blocks and there is something called input splits. Let's think about that way first. So you had a huge file, okay? Huge file like this. So let, right. So you had first line, second line, third line, fourth line, fifth line. Now fifth line was cut in between by the HDFS. Okay. It is cut in between by the HDFS over here. Similarly, then the rest of the fifth line went to the second block. This is first big block, second block over here, then third block. These are three blocks. Okay. So, and these each individual one, two, three, they represents a record. Record can be a line, a word, whatever is up to your logic, right? That is a record. Okay. Now, some of your data can be on the other side, can be on this side. Let's take a case of a general one. For time being, let's assume that each of the input split is equal to the line, file line, right? Each line is an input split for time being, right? Now, when HDFS stored your file, one of the lines who is on boundary, half of the line, half or whatever proportion, some of the line will go to the left hand side, some of the go to the next mapper. All right. Now, say for example, you had a 75 MB file. Okay. First line was hues, it was 25 MB. Second line was hues, that was 25 MB. The third line was 25 MB. Right. Now, now since first chunk can only have 64 MB, okay? First chunk can only have 64 MB. So line 3, 14 MB of line 3 was on first chunk, while the rest of it was in the second chunk, right? So your line is broken, or word might be broken, whichever is a boundary is broken, right? So therefore, the the blocks are basically need to be fixed. Okay, they need to be fixed by Hadoop so that your logic can run, basically converting a physical converting this input which is raw into a logical sense is what is called input split generation. Okay, we're preparing the input splits. So this problem is clear, right? So as we have always talked about, HDFS has 64 MB, 64 MB all the time, right? Or 128 MB. In case of Hortonworks and Cloudera, both the version shift with 128 size of the chunk. So when we always talked about fixed size, fixed size, fixed size, it also means that whether our line is starting there, ending there, whatever is happening, HDFS doesn't care and it will split it. Okay, and therefore if you try to read yourself each file and try to read the content, you will that content may not be right away useful because some of the content might be on another node, right? Therefore therefore this input, before building the map reduce, this input split size concept was created, where out of these blocks Hadoop creates input splits, right? Hadoop creates the input splits, and to do that, it tries to transfer this amount of data. This 14 MB might get transferred to the second input split, and then the work starts. So this portion of fifth will get transmitted to to the first block or to the second one, depending on the circumstances. Okay. Now, so two blocks may be on different nodes, but the split created from two blocks is on one node. Yes, that could be a one scenario. Okay. And generally input is split, which sounds equally equal to your blocks or chunks, whatever you want to call HDFS blocks. So MapReduce's input split is generally kept very very close to the HDFS block size. Okay. Otherwise, what will happen? Say you created input split of small sizes. Okay. And now there will be too much of transfer of data from here and there. So you try to keep it as close to the HDFS as possible, HDFS block size as possible. All right. So input split is an abstract class provided by Hadoop in case you want to implement it by yourself. And all you have to do is extend this input split class, tell them what is the length of each split, where is this located. Okay, this is something which framework will provide you. Now when you are defining an input format, so you'll write something. Okay, when you're defining input format, basically input format is the one which will give you the list of input splits. Okay, so here, given a context, you'll have to return the input splits, and that is basically done by creating a record reader. All right, this is done by creating a record reader. So you can actually implement input split and input format. Okay, I have not prepared an example on how to create this, but I would love to prepare one for you guys. Maybe in the next session I can demonstrate to you. All right. So input split or input format is basically a logical way of representing the data to you, to your map reducer. All right. And by the way of creating new input format, say sentence reader. Okay, if you create a reader called sentence reader, which and there is a sentence input format which will basically read the data sentence by sentence. Okay, that will be a very good exercise. All right. So basically, MapReduce, if you are coding in Java, you can actually create whatever format of the input you want. By default, it provides you the text input reader, text input format. By default, it provides you line by line. Okay, basically record is a text. Basically record is equivalent to line, which are separated by new line. Okay, so that is the kind of thing that's the default behavior of MapReduce. If you want to do that, you can implement an input format and then implement a method called get splits, and that's all. So all you need to do is keep on reading the input file in get splits and keep on returning the input split. That's all. All right. And this input split is run on each node separately, and also it communicates with the other nodes and get the results. So in our example, input split is a group of n lines. Input split is a group of n line, yes. And where n is pre-decided. So n is decided based on the size of your input split. Okay. So the total number of lines will be less than or equal to the size you have defined. So that too, I mean, it's up to you. How do you want to decide? Like, if you decide on the length here, input split, you can override it and return the value. Okay. So record, as we told, like each input split is further divided into records. Record is equivalent to lines, line one, line two, line three, and so on. Okay, and a collection of lines is equivalent to the input split. And input split is basically a cleaner version of HDFS. Input split is created from the HDFS by solving the boundary issues. Okay, it need to resolve the boundary issues, because anything which if your input record is on the boundary, then you'll need to send it to another input split. That is what is done on top of HDFS. So is it normal to decide input split as the size of complete lines? So input is split, the size is generally kept closer to the block size, which is 128 MB. So that is normal to decide equivalent to that, right? The equal to the block size. And under which you will have the lines or your input records. Say sentences. So sentences you defined equivalent to 128 MB, right? Now, the moment a sentence is on the border, so that rest of the sentence you will send it to the second node. So therefore, this chunk, the 128 MB input is split, may be little lesser than that. All right, great. Now, so what does it mean by a record? Record is what on which a map is applied. Map function when it's called on a each record by record on the whole chunk. So you have an input split, which is prepared from input split is prepared from HDFS. Okay, there is HDFS block size on top of which we have created input split. Input split is little smaller than the HDFS chunk size, little smaller because the boundary condition you had to resolve and you had to send some data to another block, another input split. Now out of this input, for each input split, the mapper, your instance of the mapper is created once for each input split. Okay, and once the mapper instance is created, we take each row and run that row, or we take each record out of this input split, run that through map. Each record, run that through map. So you understand the difference between creating an instance of a mapper and run the mapper, right? So for the whole input split, you create a single instance of the mapper. You, as in MapReduce, does it for you. These are the internal dynamics of the game, right? So each SDFS block, it creates an input split, which is little lesser than the input split. And it can mind it that it can also be greater based on how you implement the input split logic, right? But the default one, the text input split, is line by line, okay? And it's generally a little bit smaller than that. Yeah. Now, input split, which is closer to the HDFS block size, contains the logically complete set of records. Okay, complete set of records. For each set of record, for each input split, an instance of your mapper is created, and each of these records are run through. Each of these records are run through the MapReduce logic. Not map. Each record is run through the mapper. Each record is run through the mapper. All right. So that is the whole game. So record is equivalent to in our examples file line, and in the standard example you can think of each record as a row, right? Row of a database table, and each table, each chunk of the table, each block of the table, like 10 rows, 15 rows, 20 rows, is a input split. Okay. So if you are operating on a table in a distributed manner, and you have decided that 100 records we are going to keep on each node, then that 100 records are equivalent to input split. While HDFS block size might be something to do with the physical way the database is storing the files. All right. In our case, example of record is a sentence. Yes, the problem which we discussed. Okay. And if you wish, you can also think of the collection of sentences, which is a paragraph, may become your input split, but not necessarily that will become an inefficient way. All right. So this is what is the input split part. Okay. So I'll create a separate project for this, similar to what I had done just now. Let me make a note of this, and then I'll basically the case of this sentences, right? Uh, where we were trying to do a tuple analysis using sentences, that we will try to do it but and we'll explain. Maybe in the next session, I'll just upload this project. You can go through that project. In case you have a doubt, you let me know. All right. So that is input split we talked about. The next part which we want to discuss is the dynamics of MapReduce. All right. Again, because most of us had this confusion about some of it. Now, this is what it looks like beneath the hood. Okay, so we created input split. There was HDFS block size on top of which split 0, split 1, split 2 was created. Input split represent the set of data which is which makes sense because HDFS the block size blocks are basically the sum of my data might have got truncated line here half line there. That is why a logical unit is created input split. Now on top of each input split, map is run for each record, and whatever output is coming from map is being saved to the disk as it's outputting. For it keeps on writing into the memory, which keeps on persisting onto the disk. Similar in the second case, similar in the third case. Once it has done all of this, then the data is merged and sorted at a single place. Remember that before merging, sorting happens on each node. Okay, before merging. Otherwise, had it been the other way around that it will merge and then sort, then this guy would be under a tremendous load. All right, this guy will be under a tremendous load because this it has to sort as well as merge, or first sort first merge and then sort, then it will become impossible. The whole objective of distributing the code logic is defeated. So in this example it's actually a merge sort, yes. All right, so it's actually easier to I mean, are you guys convinced that merging two sorted files is easier? And all you need to do is say you have got two inputs, right? One is this. Say you have got two files. One is this file, and other is right. These are sorted, right? Now the way it is taken is that you pick up head of both the queues, both the rows. Here one and here two. We pick up a smaller one out of it. Okay, and then we compare this and this. Whosoever is smaller, we pick up that one, right? And then we have both are equal in these cases. Okay, so we pick up both. So and in the same manner we pick up 4 also, right? So it's quite a linear process. It's quite a linear process. So merging was straight away, and I did not have to apply any mind, right, in this demonstration. So this is how exactly the merging happens. So both all of these sorted it, created three separate files. Then merging started happening. It kept on reading from all and then kept on merging it. Okay. And here merge can happen by the way of a heap sort. All right. It can be by the way of heap sort, as in there is a heap of, say there are n number of input splits. There is a heap tree called heap, and in that all first element from all of these is inserted, and then the smallest one is taken out. While taking out the smallest one, figure out from which node it has come and read that file again, and then it is done. So heap sort is fairly common mechanism to be used when merging a humongous data. If you imagine that there are 10,000 nodes, 10,000 nodes, and your process is running on 10,000 nodes. So now we have 10,000 10,000 sets of data to be merged into single one. Okay. In those cases, merging that data is basically creating a heap of 10,000 node size, 10,000 element size, and keep on inserting all the values in it and then keep on taking it out. So merge is happening on one node. This is a single reducer, so it's a single node merge. Okay. Shouldn't there be a merge sort for all instances of map on every node? Right, right. So the only challenge with that one is there is too much of shuffling that will happen and that will overload the cluster. Too much of network choking will happen if they keep on sending keys to one from another, and it's very difficult to implement. Okay. Now, once that is merged, then the data is fed to your this blue one is what contains your logic. Okay. Once that happens, the reduce is run and then output is stored onto the disk in terms of part 000 or part 0001 and so on. Make sense to you? This diagram is very clear. All right, all right. Now let's move on. Now this is the case where reducer is run multiple times. Okay. Till here the process is same. Till here the process is same. Just that. Okay. Till here the process is same. Just that sort is now putting the output into two buckets. Okay. Sort is now putting the output into two buckets. Bucket one, which will go to the first reducer. Bucket two, which will go to the second reducer. In the similar manner, all of these nodes are putting the output onto these two buckets, right? Which effectively means that mapper here itself, the Hadoop knows that which key will go in which bucket, right? Which key of mapper will go to which bucket. Okay, so that is something to be understood, that when you are defining a reducer, by default it tries to do a little bit of heuristics. Okay, and it tries to run that. All right, also I forgot to show you one portion where, so in the driver there is one argument. I don't see it here. So there is a way, job dot set number of reducer task. If you say 10, so there will be 10 reducers. Okay. Now when we say 10 reducers and when we say that the in this node itself, it will create the buckets, right? So it will create 10 buckets over here and tries to guess that it does some sort of guesswork over here. And if there has been a history of your same file and it has run, that that guessing work is assisted by a bit of a history. Okay, that is a smartness which Hadoop does for you. Okay. Okay, so Rajnikant is saying why two buckets? Okay, same bucket can be shared, right? And those two buckets contain same data. No. Okay, now let's imagine that it decided that all the values below j should go to one reducer. All the values which are starting from the letter k onwards are going to go into the second bucket, right? So it has arbitrarily decided that okay, my character sets is this from 0 to 255, and I need two separate chunk. So it just arbitrarily decide that okay, all the letters who all the keys whose first letter starts with anything uh, below 255 divided by 2 is 130, right? So any letter below 130 goes to the first reducer. Any letter beyond 130 goes to the second reducer. And so it arbitrarily decides. Okay. So it divided the keys into two buckets based on how many buckets you have. And then it sent the second bucket for the merging onto the second reducer, while first bucket went to the first reducer. Rajnikant, should I explain again? No? Yes. Of course it has to be. Otherwise, what will happen is some same key will start appearing on two reducers, and the whole reducer logic, because reduce this whole map reduce says that key values of all the keys, sorry, all the values for a key should be run through a single reducer. That is the premise. All the values for a single key are to be run via one reducer, not two reducers. And if you have multiple, if you don't, if it doesn't send the same key value onto the single machine, same key to the single machine, the whole premise fails. Okay, make sense to you? Should I move on? Good. Now the other thing is, in case you know that you, in case you understand that you know your data better than Hadoop can, so you can assist Hadoop such that the buckets are this divided uniformly. Okay, you can write a code saying, okay, all the words from A, B, C, D, or all the vowels should go in one bucket. All the consonants should go in another. That you can define. Okay, to create, you can assist Hadoop in dividing your data onto multiple reducers. Just a second, I'm getting pings. Okay, I missed a couple of questions. So the input split is global in this example. How does replication? So replication will happen later. Okay, Amar. So once you have put the data onto HDFS, then the replication process will kick in from node to node. Okay, all right. Now we will talk about a bit more about. So by default, there is one. Too many reducer effort make shuffling too high. If your data is smaller, shuffling will become a very very headache task. If you have say 100 records and you have got 100 reducers, so it is going to be 100 connections from 100 nodes. So it is going to be a very big headache. Okay, and too few reducers. If there are say one reducer, and in under reducer you are doing a root mean square calculation, which requires a lot of computation. Say let's say that go through all the values and then find out all the values with respect to the same one, multiply them, and then do the square root. Okay, so if that kind of thing has to be done on a reducer and there's a lot of churning that happens on reducer, then you need to think about distributing the reducer job to multiple nodes. Okay, so too many reducers make the network traffic high, while too few reducer overloads the reducer machine and slows down the output. Okay, and therefore you need to be very cautious when you are defining reducers. Okay, and that comes with a little bit of guesswork, that how many reducers are good enough for your kind of job. That comes with a little bit of guesswork, as well as uh, you know wise decisions. Okay, So generally we tune it to the total number of slots, as in how many nodes are available, how many free nodes are available on your network. All right. Now, as an example of how do we convey to the MapReduce, to Hadoop, that hey, this is my strategy of dividing the keys amongst multiple reducer. Meaning, given a key, I should be able to tell Hadoop to send it to the first reducer, send it to the second, or send it to the third one based on the key value. I should be able to decide that. All right. Say for example, I have to I know that this age group is this one, and so on. So actually, I can basically write a partitioner, okay, by extending partitioner, and then implement a function called get partition. And based on my key, or I can return a number saying send this key to ith, send this key to nth, nth reducer. That's all. Okay, that's what this whole code shows. That based on value of age, I am sending it to the particular reducer. Right? Don't get confused by these things. Okay, you can just look at it this way. Let's say I'll actually simplify, that will make your life easier. Okay, let's say we just call it gender. All right, and we say if gender dot get string is to get the text. Okay, and we say equals, and it is male, then return 0. Okay, and if it is, or and then we say return 1, because in case it's male it will return from here itself, in case it's female it's returned once. So if you have two reducers, okay, they will be named starting from 0 and 1, right? So 0th reducer will be there, and 1 it will be, right? So they'll be named as 0 and 1, and based on the key, whatever key is there, you will return this. So an age partitioner you can define here in your code, set partitioner class, and I can say age partitioner. All right. This is the way we can do that. We can define our partitioner class like this and then do that. All right. Should I move on? Was I able to explain to you how to do that? Great, great. So this was how you decide. How do you decide that this is a partitioner? All right. Now, there is an interesting concept. Okay. Okay. So Rajnikant, just go through the video if you wish, or if you want me to explain again, I can explain again. Okay. Basically, all I'm trying to do here is I'm deciding here based on this logic. I'm telling because we got two reducer, right? We said a set reducer task equals to 2, right? Here we can do that while defining a job. We can define that, and once we have done that, either we leave it to Hadoop completely, that whatever Hadoop wishes can divide my data. But if we know that, okay, if I have a certain way to divide the data fairly, then I would do that myself by defining a partitioner. Okay, partitioner's duty is to return to return basically the a number between 0 to number of reducers you have defined, based on your logic. All right. Good. So feel free to drop me an email in case you get stuck somewhere. Now there is an interesting concept called combiner. Sure. Okay. This interesting concept called combiner. Okay. Say you have got some data over here. I'm going back to the previous screen because I hope you got familiar with this one. Let's just look at this one. So here there is a lot of data. Here there is a lot of data. Here there is a lot of data. So you have got three nodes and all three of them have some data, right? Now you know that there is a way to summarize it over here itself. There's a way to minify it. If you remember our question of counting letters, right? If you remember our question of counting letters, so on each node we will have lot of A alphabets, A these many times, B these many times, and so on, right? And you know that you can summarize it further before merging the data. You can summarize and minify the data here itself before merging it. In those cases, you can define a combiner function which is run just after sorting onto each node so that data is further optimized here itself before getting merged. All right. There are certain circumstances. If you remember our letter frequency of letters computation, if on each node itself whole of the chunk whatever is being done on that node, if we can summarize it if we can summarize it there itself on the node, then it'll be great. Remember. And the other thing is that when we say mapper, right, mapper runs on multiple record, each line by line, right? So on each node a mapper will be run maybe 1,000 times, and all the output gathered and sorted on that particular node. Okay. Now after sorting, you know that you can further process this data before merging so that your transfer cost is lowered. In those cases, in those cases, you can define something like a combiner. Okay. On each one. All right. Now map combiner runs on the same node after map has finished, processes the output of map, helps him minimize the data transfer, but it does not replace the reducer. So combiner is like a reducer which is run on that particular node. Okay. And the definition of a combiner is exactly like a reducer. It is given key and an array of values. Okay. It is given a key and array of values and it can return a value. All right. There are few qualities of a combiner. Okay. A quality of a combiner is no matter what order is given to values are given to a combiner, the output is same. Okay. Now let's take a case of a combiner over here. Because see, on a particular node, combiner might not be applied on all the values in one go. Say there are 1,000 values on a node. Combiner can also be applied on all 1,000 values in a one single sort. And combiner can also be applied in a batches of 100 each. And whatever result of that output of a combiner is, it is again given to another set of combiner, and your result is combined. Okay. So example of a valid combiner functions is count, count of values, sum of values, minimum of values, maximum of values, but average is not a valid combiner function. Okay, we'll come back to that very quickly. Now take max, right? If max is applied on all the values on a node in a single shot, right? Let's take the values for some key at 0, 20, 100, 10 and 25. So max is how much? Quickly, how much is max of these one? Quickly, just to see if you are listening to me. Okay. So 25, right? Good, good. Now, now, so whether you apply max on all these four values in a single shot is 25, right? If you do, first you apply max on 0 and 20, and then you apply max on 10 and 25, and then you apply max on these two values which came as a result. So here the max of 0 and 20 is 20, 10 and 25 is 25, and then you applied max on both of these values, then you get 25, right? Or you apply max on 0 and 10 first and 20 25 here, and you get this one. So my point is that no matter how many values you process in once, the output should be same. Only those functions are valid combiner functions, because Hadoop will do the combining in multiple sets. Okay, just like divide and conquer strategies in computing. Okay, so divide some into small batches, and then whatever results is there, again apply the same strategy and keep on solving it further. So that divide and conquer should be possible, and only those functions which have this property can be a valid combiner function. Otherwise otherwise the result may be unpredictable. Let's take a case of average or mean. In case of average, if you see the average of, what is the average of average of 0, 20, 10, 25? Quickly, can anybody? No, average of these four values. hmm I think it's 11.25. I think he's right. Yeah. Okay. Yeah, good. Good. Prashant is right. Now, now here average of these values is 11.25, but if you do average of these two values first and then whatever comes out you do the average again, you will end up with something else. And if you do that again, you'll end up with something else. So that is a example of a combiner well, invalid this is average is a bad example of combiner function. Now your to question to you is a function this function, okay, which basically returns square root of a square plus b square plus c square plus d square on, and so on, square root of the sum of squares of the values. Is it a valid combiner function? So are you clear that average, why average is not a good correct combiner function, while max, min, sum is okay? Are you convinced about that? Okay, okay. So such functions are called associative and cumulative. Okay. No matter how many values of the input are processed in one go, and we are again and again applying the same function on the output also, you should get the same result. All right. And let's go through what is max doing, or say max of these values is how much? 25. Now what you did was first computed max of first two values, then computed max of last two values, then computed the max of the results of the two operations. So max of 0 and 20 is 20, max of 10 and 25 is 25, and then we computed the max. All right. So in this case, you can see clearly that the output is output is same no matter in what order we applied the function. Is that correct, Amar? And that is not true in case of average. If you see, if you do average of all four values in single shot, you get 11.25 as result. But if you do average of these two first and then these two second, and then try to compute the average of the two, the result is different. Okay, and the result is different in the second case also, right? So that means average is a kind of function which cannot be applied, can be not be used in case of combiner, because the way we have demonstrated here, we took some values, then we took some other values, then applied exactly the same way. Exactly the same way, the Hadoop is also going to apply your function on the values. Okay, it's not necessary that Hadoop will apply the your function on all the values. Okay, this gives Hadoop a chance to divide the input and execute your function multiple times, and hence RAM will never become the bottleneck. If it has to read the whole values in a single shot and apply your function, combiner function in single shot, then RAM will become a bottleneck if the file is bigger, right? Good. So, how many of you think that this is a valid, the square root of sum of all the squares of values is a valid combiner function? Vidhi is saying that it's valid. Who else thinks that it's valid combiner function? Rajnikant thinks, okay. Prashant, good. Okay. Sai, what do you say? Vanaja, good, good. So yes, if you try to break it into first A, B, and then result of it with the C, or you try to break it, first try to do computation on only two arguments rather than three, or you try to put four into this, then you will realize no matter how you apply the function, and even if you apply again and again, you will keep the same result no matter what. All right. So that is the beauty of it. All right. And same way when you are also these combiner functions can be decided, combiner as well as partitioner, both kind of functions can be defined and utilized in case of a streaming job also, not only in case of Java but also in streaming job. In case of Java, what you can do is you can do job.set combiner. Okay, we can say this is my combiner class. All right, so you define your combiner class, which like a function, just like we are describing here. It takes an array of values, returns. The way you define combiner class in very simple word is exactly like a reducer, exactly the same footprint. Okay, same footprint. If you see set combiner, so if you see, it extends reducer. This combiner class extends reducer, which means it shows you that you can make use any class as a combiner which is extending reducer. So the footprint of the reducer class is exactly identical. Exactly. You can think of combiner as a pre-reducer residing on each mapper node. Okay. Not close to, but on each mapper node. All right. This is guaranteed to be on the same node. Because as I discussed earlier, the output of the mapper is going to be on the local file system. If a combiner is not on the local file system, it will not be able to access it. Does it make sense, Makhan? Excellent. So should we continue? I think we will take remaining tomorrow. Okay. We will discuss how can you define data locality? How can you tell Hadoop that this is the architecture of your network? These two nodes are closer and these two nodes are farther. And given any arbitrary two nodes, Hadoop should be able to figure out the distance between those two nodes that we will discuss in the next session. All right. All right. So those who are handy with any programming language, please finish your all 4 5 assignments I've given. Those who are really want to work on data scientist kind of job tomorrow after Hadoop, finishing Hadoop, they should try to solve matrix multiplication problem using MapReduce. Okay, but all of you should give it a shot. Even if you are not from programming background, you should write down in your own language and mail it to me. Write it in Google Docs, mail it to me so that I can review your code line by line and leave the comments. All right, make sense? Okay guys, thank you very much and I hope this session was fruitful. See you tomorrow morning at the same time. Bye bye. Have a great day.